Okay, so just going to run through some of these examples, grade 12s, fairly quickly. And in the first one, in sequences to infinity, obviously they're geometric sequences, we've got it in sigma notation. And generally when we saw this big sigma sign, we said, well, let's just sub in n equals 1, 2, 3, so we can see it and get a sense of it. So when n equals 1, we've got 3 over 10 to the 1. That's just 3 over 10. Plus, when n equals 2, we've got 3 over 10 squared. So that's 3 over 100. And when n equals 3, we've got 10 cubed, which is 1,000. So we have a much better sense of the sequence, perhaps, because we can see it written out. Also helps us see the common ratio. So the first term, well, that's easy, right? 3 over 10. And our common ratio, we can just see a bit easier, because if the first term's 3 over 10, and the next term's 3 over 100, our common ratio is what are we multiplying by to get from the first term to the second term? Well, clearly we're multiplying by 1 over 10. So that is our common ratio. You can kind of just see it there, I think. The more long-winded way would be take term 2 and divide it by term 1. And maybe you could see it from there or punch it in the calculator. Okay, so if a is that and that's that, well, we know that the sum to infinity is a over 1 minus r. I wouldn't even write down the a of 1 minus r. I think it's worthwhile just sub in directly that over 1 minus 1 over 10. Punch that in the calculator or do it in your head, whichever you prefer, and we'll get a third. So that's the sum to infinity of that sequence. See you in the next one.